Hello students, today we will discuss about problem related to Coulomb force. If you want to crack JEE or NEET, you have to improve your problem solving ability. In this channel, I will produce the methodical and powerful concept how to solve physics problem in various topic. So today I will discuss about problem related to Coulomb force. All of you know what is the Coulomb force. Number 1, here I will discuss the problem type by type. Type 1 is calculation of dielectric constant or relative permittivity or relative permittivity. So using Coulomb force you can calculate the dielectric constant or relative permittivity of a medium. Suppose this is the two charge. These two charge are kept r1 distance and this system are in vacuum or air. Air can be considered as a vacuum, and if the same charge and same distance, that means this system are placed in a medium where the dielectric constant is K or relative permittivity is epsilon r. Both are equal. Dielectric constant can be called as a relative permittivity of this medium. If this is the two case, here suppose the force between two charge is F of vacuum or air, and here the force between two charge is F of any medium. Then using Coulomb force you can write that F of vacuum or air equals to 1/4 pi epsilon naught. What is epsilon naught? Epsilon naught is the permittivity of vacuum, relative permittivity of vacuum, then Q1 Q2 by r square. Here it will be F of m equals to 1/4 pi epsilon, only epsilon. Here the permittivity of this medium is epsilon, and relative permittivity is epsilon r, and or dielectric constant and K. So the permittivity of this medium is epsilon, so 1/4 pi epsilon Q1 and Q2 by r square. This is the force in this medium. Here this is the force in this second medium. So if I F of vacuum or air divided by F of medium, then this and this will be cancel out, and 1/4 and 1/4 will be cancel out. 1/4 and 1/4 will be cancel out. Then here will be epsilon by epsilon naught. This epsilon or epsilon naught can be written as relative permittivity or dielectric constant of this medium. So using this formula Using this formula, you can calculate dielectric constant of any medium. If you know the force in vacuum or air, the force between the two charges, then you will be able to calculate the dielectric constant of any medium. Suppose here is 10 Newton. Here is suppose 10 Newton. Between this force is 10 Newton. Here is 5 Newton. Suppose the Newton, here is F of vacuum is 10 Newton. Here is F of medium is 5 Newton. Then the K or relative permittivity of the medium can be written as F of vacuum or F of medium. That means it will be 10 by 5. That means it will be 2. So the relative permittivity or dielectric constant of this medium will be 2. So in this way you can calculate the dielectric constant of any medium. So you have to mind it this formula. Okay, then another formula, another problem. Number 2. Number 2 is Coulomb force depends on medium. Coulomb force depends on medium. Coulomb force depend on medium. So suppose this is a charge Q1 and this is a charge Q2. These charges are kept as a distance of R1, and this is the vacuum. Here this medium is air or vacuum. If here is distance is R1, if the same charge Q1 and Q2, but the distance between two charges is R2. Now the relative permittivity or relative permittivity is epsilon or dielectric constant is K, and here K equals to epsilon R. So relative permittivity equals to dielectric constant. So if in both cases the forces are same. So in this case the force between these two charges, that means F of A, that means air or vacuum, and here is F of medium, any medium. If these two forces are same, then you have to find out the relation between R1 and R2. Here this system are placed in air or vacuum. Here this system is placed in a medium of dielectric constant K or relative permittivity epsilon R. If in both cases the forces are same, then you have to calculate the relation between R1 and R2. So here is F of air or vacuum equals to F of medium. So you can retain that F of epsilon naught into Q1 Q2 by R1 square. Here it will be 1 by 4 pi epsilon R or epsilon naught. How it is here it epsilon equals to epsilon naught equals to epsilon r equals to k. So it can be written as epsilon equals to epsilon naught epsilon r or equals to epsilon naught k, because epsilon r and k is equal. So it can be written as 4 pi epsilon naught epsilon r into q1 q2 by r2 square. So here is this and this will be cancel out, and this will be cancel out. So you here is 1 by r1 square, and here will be 1 by epsilon r into r2 square. So it will be r1 square equals to epsilon r2 square. So it will be r1 equals to root over epsilon r into r2, or it will be k into r2. This is the relation between r1 and r2. So you have to mind it that this is the formula. Using this formula you can calculate relation between r1 and r2. This is the short way. When you solve a NEET or JEE, you have minimum time, so you have to mind it in this formula. If you remember this formula, you can easily calculate the relation between r1 and r2. Suppose this is r1 is equals to here is r1 and here is r2. Suppose r2 is 10 meter, suppose 10 meter, and here k is 9, here k is 9. Then if the both cases force is same, then what will be the relation between r1 and r2? The r1 will be equals to root 9 into 10 meter, then it will be 3 into 10, that means it will be 30 meter. So r1 will be 30 meter. Here is r1 equals to r equals to r1 root over k r2. If r1 is 10 meters and r1 will be root over 9 into 10, that means 30 meters. In this way you can calculate any problem related to this. There are another problem related to dielectric constant. Number 3. Suppose this is a charge q1 and this is a charge q2. The distance between two charge, suppose d. Distance between two charge is d. The medium is air or vacuum. All the medium is air or vacuum. If I insert a medium of length t between these two charge, and dielectric constant is k, or relative permittivity is epsilon r, and epsilon r or epsilon k equals to epsilon r. So you have to find out the force between two charge. Here if the case, if the medium or is combination of two medium between two charge, how you can calculate the force between two charge? Here this is the air medium or vacuum, here is the air medium or vacuum, but in this case this is the medium of dielectric constant k. Then what will be the force between two charge? The equation is force between two charge is equals to 4 pi epsilon naught into q1 q2. Here is the charge in vacuum or air is d minus t. So here is this is a distance and this is the another distance. The total of these two distance is d minus t, and another distance is t. This t will be t root over epsilon r into whole square. It can be written as 1 by 4 pi epsilon naught q1 q2 by d minus t plus t root over k whole square. This is the equation. Using this equation, you can calculate the force between two charge. So you have to mind it this formula. If you know this formula, you can calculate easily the force between two charge in this case. This is the force. This is the another problem. Now another problem is problem number 3. This is a suppose this is a string, this is a string, and another string is, if these two strings are hanging, if I give equal amount of charge q1 and here is q, then what happen? The next it will be repel each other. So when it repel each other, then it will be here and this will be here. So here you see that these two balls are hanging through a wire or string. If I give equal amount of charge to this bob or ball, then these two balls are repel each other. When they repel each other, they are go away from each other. In stable condition, you have to find out the tension of this wire, and you have to find out the angle between this charge, angle between this, you have to calculate the theta tension. So how you can calculate? Here is suppose mass is m, here is suppose mass is m. So the weight is along this direction, and Coulomb force, this is q and this is q. So Coulomb force along this direction, that means F. What will be the F? F equals to 1 by 4 pi epsilon naught if this system is placed in vacuum. Suppose this system is placed in vacuum or air. So F equals to 1 by 4 pi epsilon naught q1 q2. Suppose this is a distance, this distance is d. Suppose this distance is d, then it will be d square number 1. So if this is a tension of this wire, then if this is a theta, then it must be a theta. If I regulate this tension, then along this direction it will be t cos theta, and along this direction it will be t sin theta. So at stable condition, at stable condition, the total force on this ball or bob will be 0. That means this force and this force, opposite force, must be equal. So here T sin theta will be F, that means 1 by 4 pi epsilon naught into Q1 Q2, that means Q1 Q2, that means both are Q, so it will be by d square. Here is both are Q, so it will be 1 by 4 pi epsilon naught Qa square by d square. This is the equation number 1. This is the equation number 1. Now this force must be equal, so T cos theta equals to mg. This is the number 2. If I ratio these two equations, that means 1 divided by 2, then it will be T sin theta divided by T cos theta equals to here is F or this. So if I use F, then F divided by mg, then it will be tan theta equals to F by mg. If I put this value, then it will be 1 by 4 pi epsilon naught mg d square, and here will be q square. This is the another equation number 3. So using this formula you can calculate the theta. So if you know this theta and the length of this wire, then you can easily calculate the distance between two charges. So another calculation is you have to find out the tension of this wire. So to calculate tension of the wire, if this is a formula, it can be written as F, that means it will be number 1. Then if I number 1 square plus number 2 square and then add it, so it will be T square sin square theta, and here will be T square cos square theta, T square cos square theta. Then in the left side it will be F square plus mg square, sin square theta. If I take common T square, then it will be sin square theta plus cos square theta equals to F square plus mg whole square. Then this is 1, so T equals to root over F square plus mg the whole square. This is the fourth equation. So using this formula you can calculate the tension of this wire. Using this formula you can calculate the angle in this angle. So if you can calculate this angle, then it will be easy to calculate the separation between these two charges. So this is the formulas. Now number 1, if this system is placed in moon, if this system is placed on moon surface, then what happened? So if this system is placed on moon surface, then what happened? Here in moon surface, the weight of this bob will decreases. So if weight is decreases, suppose suppose the medium of on moon surface is vacuum, so force will remain same. So force here is force F remains same, same because there is a vacuum. Now, but this mass, that means weight, here is weight will be decreases will be decreases. If weight is decreases, using this formula, if weight is decreases, then T will be decreases. So decreases. So if weight of this mass is decreases, because the G in moon surface is less than the G in earth surface. So if this system is placed on the moon surface, then the force between the two charges is remain same because there is a vacuum. Number 2, here is G is less in moon surface, so the weight of this mass will be decreases. If weight is the mass is decreases, then tension of this wire is decreases, that means T will be decreases. If T is decreases, then using this formula, if T is decreasing, that means F is decreasing. So F is decreasing, though using this formula you can calculate that. So if F is decreases, then the distance between two charge will be increases. So if F is decreasing, F, that means tension is decreasing, not F. Here is tension is decreasing. If tension is decreasing, then using this formula, here is that T is proportional to 1 by d square. So here is T decreases, so D must be increases. So D must be increases. So what happened? Here this separation between charge will be increases. So if this system is placed on moon surface, then separation between two charge will be increases. Number 1. Number 2. If this system is placed on elevator, then what happen? When elevator is moving, when elevator is moving with constant velocity, that means V equals to constant, that means A equals to 0, that means the acceleration of the elevator must be 0. If acceleration is 0, all the function remain constant, that means all the parameter remains same. All the parameter will be remain same. But in this second condition, if the elevator, suppose this elevator number 2, here is number 1, is when elevator is moving with constant velocity. That means if the system on the elevator and elevator moving upward with constant velocity, if constant velocity there is no acceleration, so if there is no acceleration, this apparent weight remain constant. So if apparent weight is remain constant, so all the parameter will remain same. But when the elevator, suppose this is the elevator, so this elevator is moving upward with acceleration A, then what happened? If the system on this elevator and elevator moving upward with acceleration A, then the apparent mass will be increases. That means apparent mass is equal to apparent mass, that means W this apparent weight, not apparent mass, apparent weight increases. If apparent weight is increases, then tension will be increases. So if tension is increases using this formula, here is see that T proportional to 1 by d square. If T is increases, so D must be decreases. So using this formula, so in this case, the separation between two charge will be decreases. So when elevator is moving upward with acceleration a, then this system, the separation between two charge will be decreases. This is the condition number 2. When suppose this elevator is moving down with acceleration a, then what happened? If the elevator is moving down with acceleration a, then the apparent mass will be decreases. If apparent mass is decreases, so using this formula, then the tension between two charge, tension of this wire will be increases. Apparent mass is decreases, so it will be decreases. So tension will be decreases. If tension is decreases, so must be this D will be increases. So this D will be increases. So third number condition, if the elevator is moving down with constant velocity, then apparent mass of this bulb will be decreases, and if apparent mass is decreases, then the tension of this wire is decreases. If tension is decreases, then the separation between two charge will be increases in this condition. Number 4. Suppose this is a number 4. Number 4 is when it is a free fall, that means A equals to G, that means free fall. If elevator is free fall, then what happen? If elevator is freely fall, then what happen? The apparent mass will be 0. The apparent mass will be 0. Apparent weight must be 0. If apparent mass will be 0, the tension equals to the force between two charge. That means in this condition, it will be along this direction. This is Q1, this is Q, and this is Q. So this is the tension, and this is the tension. This is the F. If apparent weight is 0, that means there is no force to protect this system. So this system will be in this way. Here is the point. Here is point A. Suppose this is a point A. So when apparent mass, when this free fall, then this mg will be 0. If mg will be 0, then this system will be in this way. So when the elevator is free fall, then the charge, these two charge will be the maximum distance. These two charge will be two charge are in maximum distance. That means what condition? In what condition the distance between two charge will be maximum? The maximum is the length of this wire and length of this wire. Then when this system is free fall, then between two charge, distance between two charge will be maximum. Maximum. Number 3. Another number 5. If this system is placed on, suppose if the system is placed on satellite, if the system is placed on satellite, then what happens? In satellite, the apparent mass is 0, apparent weight is 0. You have already learned in class 11 that on the satellite the apparent weight will be 0. If apparent weight is 0, there will be no force, that means there is no mg, so it will be like this is condition, this is q, so this is f, and here this is f, and this is t, it will be the maximum condition. That means when the elevator is on free fall, and if these system are placed on satellite are same, if this system are placed on satellite, then the separation between two charge will be in maximum point. This is the